A blockchain is a decentralized and distributed digital ledger used to record transactions across multiple computers in a way that ensures the security, transparency, and immutability of the recorded data. At its core, a blockchain is a chain of blocks, where each block contains a set of transactions. Here are some key features and characteristics of a blockchain. Decentralization. Traditional databases, such as a relational database management system, RDBMS, are centralized. In contrast, on the blockchain, every participant, node, on the network has access to the entire database and the complete history of all transactions. Transparency. Changes to public blockchain are publicly viewable by all parties, creating transparency. However, personal identities are hidden, offering a level of anonymity. Immutability. Once a transaction is added to the blockchain, it becomes unchangeable, meaning that no one can tamper with the transaction after it's been recorded. Consensus algorithms. This is a technique used to achieve agreement on a single data value among distributed processes or systems. Popular consensus algorithms include proof of work, POW, and proof of stake, POS. Cryptography. Transactions are secured using cryptographic principles, which ensures the security of data and transactions against malicious activities. Smart contracts. These are self-executing contracts where the agreement or conditions are written into lines of code. They run on the blockchain and automatically enforce and execute when certain conditions are met. Pseudonymity. Every transaction that you do through cryptocurrencies like Bitcoin doesn't show who did the transaction. Instead, it shows the address of the transaction. Trustless system. You don't need to trust the other party or a third party, like a bank, in the transaction process. The decentralized and cryptographic nature of blockchain ensures that. Security. Due to its decentralized nature, the blockchain is highly resistant to malicious attacks. If an attacker wants to alter any transaction, they would need to alter all subsequent blocks, which is computationally infeasible for large chains. Applications of blockchain go beyond cryptocurrencies like Bitcoin or Ethereum. It's being explored in various sectors like finance, supply chain management, healthcare, real estate, and more, due to its potential to provide transparency, traceability, and enhanced security. However, while blockchain has many advantages, it also comes with challenges such as scalability issues, energy consumption, especially for POW-based blockchains, and regulatory concerns. Blockchain technology addresses several needs and challenges in various sectors, making it a sought-after solution for various applications. Here are some reasons why blockchains are considered valuable. Reduction in fraud. Given the decentralized and transparent nature of blockchain, it is difficult for any single entity to manipulate the data, reducing opportunities for fraud. Cost savings. By eliminating intermediaries, many blockchain applications can lead to cost savings. For instance, bank wire transfers that might take days and cost a significant amount can be done in minutes at a fraction of the cost with cryptocurrencies. Smart contracts. These self-executing contracts automate and streamline processes, ensuring that contract terms are met automatically without the need for intermediaries. Supply chain and provenance tracking. Blockchains can provide detailed and tamper-proof records for supply chains, ensuring authenticity, origin, and touchpoints of products. Financial inclusion. Cryptocurrencies on the blockchain can provide financial services to those without access to traditional banking systems, especially in underserved regions. Ownership and rights management. Blockchain can be used to manage and verify ownership rights, whether it's for digital assets, Real estate or intellectual property. Interoperability. Different blockchain networks can be made to communicate with each other, facilitating a more connected and integrated system. Innovation. Many industries see blockchain as a foundation for new business models, opening up possibilities for decentralized applications, dApps, decentralized autonomous organizations, DAOs, and more. The operation of a blockchain can be understood in terms of its structure and processes. Let's break down the workings of a typical blockchain. Structure. Block. The primary unit of a blockchain is a block. Each block contains a header, which includes metadata, such as a reference to the previous block, called the parent hash, a timestamp, and other relevant information. A list of transactions, which represent the actual data stored on the block. Chain. Blocks are linked in a linear sequence, forming a chain. Each block references the one before it, creating a traceable history back to the first block, called the genesis block. Processes. Transaction creation. Users initiate transactions, which can represent various actions depending on the blockchain's purpose. For a cryptocurrency blockchain, a transaction might represent a transfer of coins. Transaction verification. Before being added to a block, transactions are verified by network nodes. This ensures the transaction's authenticity and that it doesn't conflict with others. Consensus mechanism. Once transactions are verified, they need to be added to a block. However, deciding which block gets added next requires a consensus mechanism. Common mechanisms include proof of work, POW. Participants, miners, solve complex mathematical puzzles. The first to solve it gets to add the next block. This method is energy intensive. Proof of stake, POS. Participants are chosen to create new blocks based on their stake, amount of cryptocurrency held, and other factors. Block addition. Once consensus is reached, the new block is added to the chain, creating an immutable record of the transactions within it. Chain verification. Every node in the network keeps a copy of the blockchain. When a new block is added, nodes verify it against their own copy to ensure consistency and integrity. Fork resolution. Sometimes, two blocks might be added to the chain simultaneously, creating a fork. The blockchain resolves this by following the chain with the most cumulative work, in POW, or other criteria depending on the consensus mechanism. The other block gets discarded. Rewards. In many blockchains, participants who contribute to block addition, like miners in POW systems, receive rewards, incentivizing them to continue participating. Additional features. Public and private keys enable secure transactions. Hash functions ensure data integrity and are used in block headers to link blocks. The development and proliferation of blockchain technology involve a diverse set of individuals and entities. Here's a breakdown of the key players. Satoshi Nakamoto. The pseudonymous individual or group of individuals who published the Bitcoin white paper in 2008 and released its software in 2009. Nakamoto introduced the concept of a decentralized ledger, blockchain, to solve the double spending problem without the need for a trusted third party. Cryptographers and developers. Many cryptographers and software developers have contributed to the development and refinement of blockchain technology. They work on improving the efficiency, security, and functionality of blockchain protocols. Miners, for POW blockchains. Miners use computational power to solve complex mathematical problems, validating transactions and adding new blocks to the chain. They are crucial for the security and operation of proof-of-work blockchains. Validators, for POS and other blockchains. In non-POW systems like proof of stake, POS, participants called validators replace miners. They are chosen to create and validate new blocks based on various criteria. Node operators. These individuals run nodes, which are computers that maintain a copy of the blockchain and validate transactions. Nodes help in decentralizing the network. Blockchain companies and start UPS. Numerous companies are developing blockchain-based solutions, applications, and platforms. Examples include Ethereum, Ripple, and Chainlink. These companies might offer blockchain infrastructure, services, or specific applications like decentralized finance, DeFi, platforms. Investors. Both institutional and individual investors have shown interest in blockchain technology and cryptocurrencies. Their investments fuel the development of projects and start UPS in the space. Researchers and academics. Many universities and research institutions are exploring the potential, challenges, and implications of blockchain technology. Their insights help in refining and expanding the technology's applications. Regulators and governments. As blockchain and cryptocurrencies grow in popularity, regulators worldwide are working to understand the technology and develop frameworks to ensure its safe and legal use. Advocacy groups. Organizations like the Electronic Frontier Foundation, EFF, and the Blockchain Association promote the adoption of blockchain technology and advocate for policies that foster innovation while protecting users. End users. Regular users who use cryptocurrencies for transactions, invest in them, or use blockchain-based applications contribute to the ecosystem's growth and evolution. Enterprise and consortium blockchains. Several enterprises and consortiums, like R3's Corda and the Hyperledger projects, are developing blockchains tailored for business use cases. It's worth noting that the blockchain space is highly collaborative, with many individuals and entities often working together in open-source environments to drive innovation and improve the technology. Applications of blockchain go beyond cryptocurrencies like Bitcoin or Ethereum. It's being explored in various sectors like finance, supply chain management, healthcare, real estate, and more, due to its potential to provide transparency, traceability, and enhanced security. While blockchain has many advantages, it also comes with challenges such as scalability issues, energy consumption, especially for POW-based blockchains, and regulatory concerns. A blockchain operates by collecting and verifying transactions, reaching a consensus on the order of these transactions, and then adding them to a shared, immutable ledger in a way that is transparent and verifiable by all participants. This decentralized and cryptographic approach ensures that the data on the blockchain is secure, transparent, and tamper-proof. Despite these benefits, it's essential to understand that blockchain isn't a panacea for all problems. There are cases where traditional databases or systems might be more efficient. The decision to use blockchain should be based on the specific needs of the application and the problems it aims to address. Now you know what blockchains are. Thank you for your time.